Okay, so we finished up page 7 on Friday, but I know that was like forever ago. And we had a long weekend and we were a little crazy. Some of you were sleep deprived on Friday. So I just want to go back here. I'm actually going to go back quickly to the latitude side. What if I said I went outside last night and I saw Polaris, the North Star, and I saw it at 42 degrees in the sky? Where could I have been? Hint, use your reference table. So I'll say it again. I saw Polaris at 42 degrees in the sky. Where could I have been? I'm not telling you what page. You need to figure that out on your own. What city could I have been in if I saw Polaris to be 42 degrees in the sky? Heard a couple answers: Kingston or Albany, Jamestown. Could Ithaca?
Buffalo? No, is that right on 42?
So what are you guys doing? How do you know anything? I try to talk about latitude. I was talking about altitude of Polaris. So what are you guys doing? You were right. So what did you do? What did you need to know? Huh?
I think the degree.
So what I'm getting at is you needed to know this right here. So what you need to know is that the altitude of Polaris, so how high in the sky Polaris is equal to your latitude. So I said that Polaris was 42 degrees in the sky. So it's 42 degrees high. So I take that to a map. And since I said city, so this goes back to Phoenix asked me what page in our reference table. Since I asked what city, what pages in our reference tables talk about cities? This is the only one that's got cities on it. The map of the world doesn't have cities. It's got countries and plates labeled. The other landscape feature one doesn't have cities. So this is the only one that has cities. So that's your first clue. So you got to look for clues in the question for what page to use. So if it says what city, you're going to be using a map that has cities labeled. If you're looking for like general world locations, that's going to be pages 4 and 5. So again, you needed to know that altitude of Polaris equals your latitude. So here is your latitude. So remember, latitude, latitude, you are always welcome to use a ruler. So latitude goes this way. So there's 42. And there's a bunch of cities you could have been. So Jamestown's pretty darn close to 42. Elmira, Binghamton, Slide Mountain. I think Kingston is right under there, isn't it? Yep. Kingston's just below 42. So those of you who said Buffalo would see it more at 43 degrees in the sky. Same with Ithaca, that'd be 42 and a half. Since there were so many right on 42, that should have been one of your answers. So again, you need to know that. So I don't know if you saw over on the board, we're going to have a quiz on chapter 2, which is everything we've done so far in the packet on Thursday. That's going to be on the quiz multiple times. You need to remember that when the question is asking about altitude of Polaris, I want you thinking in your head, altitude of Polaris equals latitude. You'll always get the answer. So don't say anything out loud. Where in the sky would you look for Polaris if you were in Watertown? So don't answer out loud. I want everybody to think of this answer. Where would you look in the sky to see Polaris if you were in Watertown? Don't answer out loud. Find your answer first. Where would you look in the skies to see Polaris if you were in Watertown? If you can't find Watertown, I'll give you a hint. It's right there. So right up the corner of Lake Ontario. You guys answer, Olivia? Whereabouts would Polaris be in the sky for Watertown?
43.
Nah, not 43 for Watertown.
44.
Yeah, it's much closer to 44. You're right, it is really 43 degrees, 55 minutes north. But because it's so close, we would look at more 44 than 43. Wanna try one more? If you were in Messina, where would you have to look to see Polaris? So here's one more question. If you were in Messina, where would you look to see Polaris? Messina, where would you look to see Polaris? Okay, Polaris, or Messina's practically Canada. Way, 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 way up north. Chris, you find an answer? Where would you look to see Polaris if you were in Messina? Okay, so you could just go with 45, and it's way more than 3/4. It's practically right on there. No, remember, we have 2 minutes if you're gonna go with that. So that would be 44 degrees and 55 minutes. I think you might have been thinking of longitude, Chris, because it is 3/4 of the way longitude, but latitude it is really close to 45. So that's what we did on Thursday. On Friday, we started talking about time zones. Do you guys remember how many time zones there are on Earth? Yeah, there's 24. There is one time zone for every hour of the day. Do you remember how far apart those time zones are?
15 degrees.
15 degrees. Do you remember where that 15 degrees came from? Not the equator. No, that's not it. Anybody remember the math? Yeah. So we did put all those notes here. I just realized I want to put that same summary pretty much right here on page 16. So if everybody could turn to page 16, we just need to summarize time zones. And I think you already started to summarize them for me. Now I already have the word Earth there. So here's what I just asked. Where did those time zones come from? The Earth, well, it rotates at a speed of 15 degrees every hour. And where does that 15 degrees come from? You take that 360. So a 360 is one full turn. And divide it by 24. So it's 24 hours to do that turn. So 360 divided by 15. No, 360 divided by 24 is 15. So that's why the time zones are also 15 degrees apart. It's because that's how fast the world is spinning. The next bullet says meridian lines. Do you remember what a meridian is? Some of you are nodding. We did this earlier, this chapter. What's a meridian? The line of longitude. So the lines of longitude on the globe, so the meridians are drawn based on Earth's rotation. One line for every 15 degrees. So that goes in where it says meridians. And I have a feeling you guys already know pretty much everything we need to know about time zones. So you know they exist, right? We got the Bills game coming up on Sunday. What's so special about this coming up Bills game? It's in London. It's actually our home game. It's a home game, but it's in London. You did not know that?
Didn't Tom Brady play? Was it different last year?
Do I know anything about Tom Brady? I know we're supposed to hate him. That's all I know. And he just got divorced. All I know about him.
It was terrible.
I have not seen him recently. We're not buds or anything, so I haven't run into him. Do you? Me neither. You're going to find out very quickly, Phoenix. Nothing. I know that was supposed to watch Bills. I know how. But anyway, I knew because I'm planning a party. I knew that they're playing in London. I know it's our home game, but we get to play in London. Why they're doing that? I guess to try and get some London people to watch the NFL. That sounds like what's happening. Anyway, so we've got this Bills game coming up in London. So besides Phoenix, because he clearly didn't know, does anybody know what time the game starts for us. I think it's at 9:30.
Yeah, in the morning.
9:30 for us. Do football games and football players typically play games at 9 o'clock in the morning or 9:30?
Oh.
No, that's just weird. Does anybody know what time it really starts for those players
You know,
in
like
London?
6 hours ahead.
Wow, I didn't know fancy. I know it starts at 2:30. Still a weird time for a football game to start, but it starts at 2:30 in London. So it's 2:30 in London, but we have to watch it at 9:30 in the morning. Weird, right? So what do we know about time zones? If we go to London, what happens to the time? It does change. It gets what, Drake, hang on, don't forget your question. Drake, what words just came out of your mouth? It goes ahead. Which way is London on a map? It is east of us. So, and how did you guys know it? Well, so that's what I want to do. Right there in your notes, I already say, if you go east, here's what happens with the time zone. And you already figured this out based on the Bills game. So if we go east towards London, they actually go ahead of us. Phoenix, do you remember what your question was gonna be?
Yeah, like I heard flying over. Does your phone time change?
Yeah, and so because you have to go, you're supposed to be in airplane mode on a plane. It won't update until you hook up to the regular internet again. So when you're going, your phone will stay, because you're in airplane mode, it stays the same as when you took off. But then as soon as it hooks up to the right, like you get off of that airplane mode, it tweaks. And maybe if you're hooked up to the Wi-Fi on a plane, it changes automatically, but I've never been hooked up to the Wi-Fi on a plane.
You were on a plane?
Yeah, just went to Oregon this past summer. And which is why I can say for sure that it didn't update until I landed. So if you're going east, it's going ahead. So right now it's later in the day in London. So on Sunday, when we're here watching the Bills game at 9:30 in the morning, it's going to get later in the day as we go towards London to 2:30 when we get to London. Now, how about going west? So out towards California, or where I went in Oregon. Anybody know any of you guys been?
3 hours.
Not ahead. They're behind us. Have you guys ever heard of like the Old West? Like, what do you picture when you picture like Old West stuff? Cowboys, and they're like in saloons and they're shooting each other in the streets, right? Horses, no cars. Olden days, right? If you think of the Old West, what do you say? Yeah, similar to the Amish nowadays, but so what I'm getting at is I picture Old West stuff as like the olden days, like back in the past. That's the same deal. When you go west, it gets to be earlier in time, not by decades, like I'm talking about, not by centuries, but at least by an hour every meridian. So there where it says, if you go west, you go back in time 1 hour per meridian. So that goes where it says, if you go west, if you go west. So that's how I remember, because if you go to the Old West, you're going back in time. Mrs. Ritz. Who? Mr. D? Yes, go ahead. It's for you, Mr. D. It's Mrs. Slocum. So just remember, when you go in the West, we're just going back in time. And it's an hour per meridian. So you knew it was 3 hours. Have you been somewhere?
Yeah.
No, you just knew that. You have been to California?
Okay.
I have not been to California, but like I said, I've been to Oregon. And it is 3
Okay.
hours between here and my
That's fine.
brother.
Is Eastern Standard Time? How is that most common? Like,
Because that's just where we live. So yes, Eastern Standard Time, it's New York City, it's us, it's the whole East Coast. So the East is a little more populated than everywhere else. And around here, they're only gonna talk about Eastern Standard Time for the they won't often talk about the other ones because we don't live there. But the news reports and stuff, like in California, they don't talk about Eastern Standard Time as much. They talk about Pacific Time. But they do have to deal with it a little bit more because a lot of stuff is centered around New York City and stuff on the East Coast. But anyway, going back to this whole Bills game, My brother is a crazy, freakish Bills fan, like watches everything, owns all the merch, obsessed. What time is he gonna have to watch the game? No, he lives in Oregon.
Oh,
6:30 in the morning. Not that bad. Okay, so also he's an adult. Typically, how do adults enjoy Bills games? Okay, there's usually some drinking involved. It's not coffee. It's not coffee that my brother is usually consuming while watching these Bills games. It's gonna be 6:30 in the morning.
Hey, you start with 6 in the morning, then you work
Oh.
your way up throughout the day.
That, I call him a kid because he's 6 years younger than me, but man, that guy is going to have to pace himself or else he's gonna have a hangover by noon. He has to start watching the Bills game at 6:30 in the morning. Can you imagine? Like, who gets up at 6:30 on Sunday?
my dad.
Yeah. Yeah, I'm not ready to do that. 6:30 on a Sunday. Luckily, he's got a newborn still, so he is probably up by then, but he's probably pretty tired. By the way, do you guys remember the 180 longitude line? There's something special about it. The next bullet there. 180 degrees longitude. Anything special about that number? It's not the prime meridian. What's the longitude of the prime meridian? 0. Does anybody remember? It's where it switches. It's the halfway mark. The halfway mark, and what happens when you cross the 180 degrees? Oh, I guess I didn't want you to know what happens when you cross the 180 degrees. When you cross the 180 degrees, what did I want to write there? You change days. When you cross the 180 degree day line, you change days. If you cross the 180 between us and wherever you're going, it's going to, depending on which way you're going. If you're going east, it's going to become tomorrow. If you're going west, it's going to become yesterday. Weird, right? It's like time travel.
So if I gotta calculate right now,
We won't cross the 180 to go to California.
so I'm planning to plan land over the. Second across the 100.
No, so it's just compared to us. So it will still work like, it will still work, yes, slowly. Does anybody remember why it would, what's so like, it's got a name. So since it changes days, do you remember its name? The 180 line wasn't the prime meridian. It's the international date line. That's the date part. So not like going on a date with someone from a different country. Get it? International date. No. Sorry, no, not that. So there's not much that you have to remember with lines of longitude and time zones. But the things you have to remember is how far apart they are, 15 degrees. And then if you go east, it gets later in the day. And if you go west, it gets earlier in the day. So let's try this out. You have a map right here on page 17. To make your lives easier, if you flip over to 19, you can actually just gently rip that one out. It's the same page. So don't destroy your packet, but gently rip 19 out, and then let's go back to 16. It's the same map on page 17, but I thought it'd be easier if you could just take it out and have it next to it. Yeah, so page 17 and page 19 are exactly the same. Why I didn't just put a blank sheet so you could take it out, I honestly have no idea. Yeah, 17 has stuff on the back, 19 doesn't. So you see this map is what you should be looking at. And we're going to answer those 5 questions on the bottom of page 16 right now. So it starts with, according to the map, what time is it here in New York State? Oh, before we get started, I want to talk about what's weird about this map compared to our reference table. Grab your reference table, map of the world, page 5. So sorry, I got a little bit ahead of myself. So have this map next to page 5 in your reference table or page 4, either one. What's you know the games like spot the difference? Yeah. Can you guys spot some differences? So we're looking at page 4 and 5 compared to the map I just had you rip out.
More people.
Which, so what did you say, Drake?
That's my 25 players.
Okay, so yes, so the map on page 5 has plate tectonics with different details on it. So yep, that's one huge difference. Keep spotting some more differences.
Equator line.
Well, okay, so we drew in the equator line.
Opposite, like,
That's one thing you should be noticing. On this map that you just ripped out, North America's over here on the left where you're used to looking at it. In our reference tables, it's over on the right. Who remembers why that's like that? We talked about that already. Do you remember why, Olivia? Do you remember why page 5 and this map are different? So I have page 5 right here. Who remembers why North America's on the right on page 5, but on the left on this map? What's different? Guys, remember why? Did we just change the world? No, no, that's not it. We kinda did, but how? What changed? What? Yeah, it's from the perspective of how we're looking at it. In your reference table, guys, please never ever forget that the prime meridian's way, 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 way over here on the left of the paper. Where's the prime meridian on this map?
little.
Down the dead smack center. Here's the prime meridian on this map. So it's still the same concept. It's just moving the reference table around. All right. So that's one difference. What's another that you should notice? There's another big, huge difference on here.
180 on the right.
Okay, so same deal. Yep. So 180 up here is off on the sides. We're on our reference table. It's almost down the middle. That's another difference. You should be spotting another difference. Chris, do you see anything? Right. And that's again because the prime meridians move. There's still something big. I need you guys noticing this difference. So if you're working on your problems, you're not listening to me. So I need you guys to follow along. There is another huge difference between this map on page 19 and your page 5. I'll give you a hint. It has to do with numbers. Phoenix, pay attention. Guys, notice anything big difference with the numbers? Let me rephrase this. You should notice a difference with the numbers.
15,
So this map, they're going up by 15s. Let me show you what I mean in case you didn't notice. 0, 15, 30, 45, 60, 75, 80, 90, 105. They're going up by 15s. What are they going up by on this map? 20s. So 0, 20, 40, 60, 80, 100. Why is it a problem that this map goes, page 5 goes up by 20s and not 15s? Oh, guys, we got to get these brain juices flowing. Why might this be a problem that page 5 goes up by 20s and not 15s? Thank you. My question was, why might it be a problem that your reference table goes up by 20s and not 15s? Why might that be a problem? Why? But why? What is 15 such an important number?
Oh, cause, the green of the hour.
That's what the time zones are going up by. So this map, we're not gonna be able to do time zones very easily on this map in our reference table because they're going up by 20s. Can you still figure it out? Yes, but you're going to have to like do math. So you always, guys, anytime I give you a map, actually, anytime I give you anything, what's the number one rule? Read not just the directions,
Everything.
everything. And when I say read everything, I mean when you get a map in front of you, one thing you're going to have to do is read the numbers to see what they're going up by. And if it's a time zone question, they need to go up by 15s. If it's a time zone question, the magic number is 15s. All right, so now let's see if we can do this math, these questions on page 16. The first question says, according to this map, what time is it here in New York State? So New York City is labeled, that's close enough. Here's New York City. What time is it? Yep, follow that up. Luckily, someone labeled it for you. It is 10 a.m. in New York City. So that is right here, 10 a.m. So then if it's 10 a.m. in New York City, we now want to know what time it is in San Francisco. Here's San Francisco, way over here. So first of all, are we going east or west? Yeah, this going this way is west. So does it get earlier or later in the day? Earlier. So if this is 10, this will be 9, 8, 7. Anytime it has to do with time, you need a label, AM or PM. So is it AM or PM in San Francisco? Yeah. If it's 6 p.m. in Volgograd, what time will it be in London? So here's Volgograd, 6, was it PM?
Yeah.
Yep, 6 p.m. and we need to go to London. By the way, the dot for London is behind the word. So again, are we going east or west? When we're going from Volgograd to London, it's going west again. And just like when you go out to the Old West, it gets earlier in time. So there's 6. No, we're going this way. So this one is earlier. So 5, 4, 3. That one will be 3 p.m. How about, according to the map, what time would it be in Osaka? Osaka, here's the dot for Osaka. It's again in front of the word. So here's 10 p.m. I'm going to follow this line up. So we're going here. There's 10 p.m. Are we going east or west? So from 10 p.m., are we going east or west to get to Osaka? We're going east. So does it get earlier or later in the day? Later in the day. So there's 10 p.m. What's this line? 11. And then the line that Osaka's on? 12. Will that be 12 a.m. or p.m.? This is a.m. Midnight is a.m., guys. So it'll be 12 a.m. in Osaka. So that's my next question. Is it going to be today, tomorrow, or yesterday? Yeah, it'll be 12 a.m. the next day. And then how about in Nome? Here's Nome, Alaska. We know this 10 a.m. line, and we can bring this up if that helps. So are we going to go east or west from the 10 a.m. line? This way. Is that east or west?
Wait, west.
That's west. So we gotta get earlier in time. There's 10 a.m., 9, 8, 7, 6, 5, 4. 4 a.m. Is that going to be today or tomorrow or yesterday compared to us in New York City? Yep. So if it's 10 a.m. for us, it'll be 4 a.m. in the morning today. So since we have a test coming up on everything we've done in chapter 2, we need to make sure you're good with the Regents question. So your homework is pages 14 and page 15 in the packet. So we're going ahead one page, sorry. pages 4 or back, I guess, I'm sorry, pages 14 and 15 has all to do with latitude and longitude. What if you will need your reference table to answer these. So this is not a request. This is an order for you to start your homework right now. I also want to remind anybody who has been absent any days, you might want to check Power School, because if you had homework and you never turned it in to me, you have zeros in there. So you need to make sure when you're absent that you get homework done. Since it's early in the year, I will let you turn in your missing homework for a penalty. But from now on, after this 5-week mark, if you don't turn it in, it stays a 0.